So yesterday or the day before we did adding and subtracting decimals. So just to recap, when you're adding or subtracting decimals, you need to line up your decimal points, add zeros if necessary, and then you just add or subtract like normal and bring the decimal point straight down. Today we're going to do multiplying decimals. I actually think that this is way easier. So to multiply decimals, you do not need to line up the decimal points or add zeros. Okay, so you have to line up your decimal points, very important for adding and subtracting, but not necessary at all when multiplying. You can, but it's going to make it just longer and harder. So why would we want to make it longer and harder? Put the number with the most digits on the top, and then multiply like normal. Here's how you figure out where your decimal point goes in your final answer. Count how many digits are to the right of the decimal point for both numbers. This amount tells you how many digits must be to the right of the decimal in your final answer. Okay, so there's some examples on here that you guys can look through, but I'm going to have you flip over your notes and we'll just get right into some practice problems. So let's try this first one. Actually, I'm just going to have you guys watch. So first we put the number with the most digits on top. So that would clearly be this one. So I'm going to write 3.91. 6 is going to go to the bottom. We just kind of lined up, pretend it's almost like it's just 391 times 6. So you don't have to line them up. It makes it way harder to do that. I'm going to multiply like normal. 6 times 1 is 6. 6 times 9 is 54. So I carry the 5. 6 times 3 is 18. Plus 5 is 23. Now how I figure out where my decimal point goes is I count how many numbers are to the right of the decimal. 1 here, total of 2. 6 doesn't count because it's not a decimal, it's a whole number. So I have 2 numbers to the right of my decimal. So I have to place my decimal point in my final answer so that there's 2 numbers to the right. So if I put it here, I have my 2 numbers to the right. That's my final answer. Okay, I'm going to try one more and then I'm going to give you a couple to try. So the number with the most digits goes on top. The second number just kind of gets smushed to the right. Multiply like normal. So 3 times 6 is 18. Carry the 1. 3 times 1 is 3. Plus 1 is 4. 3 times 0 is 0. 3 times 0 is 0. These zeros are necessary because you probably need them as placeholders when you put your decimal. Now I'm going to count how many numbers are to the right of the decimal. There's 3. The whole number down here doesn't count, so 3 numbers to the right. So I'm going to put my decimal here, so I have 3 numbers to the right. And that's my final answer. So I'm going to have you pause and try these two. Okay, this one says, how high is a stack of 100 dimes? Each dime is 1.35 meters. I want to show you a really cool trick. This only works when you're multiplying by a power of 10. So that means like 10, 100, 1,000, million, so forth. So if you are multiplying by a power of 10, what you do is you count how many zeros are in the power of 10, in this case 2, and you move the decimal that many spots to the right. So that answer is actually 135 without doing any multiplication. So this is a trick that you can use. It only works if you're multiplying by a whole number power of 10 though. If you forget this trick, you could easily just do 1.35 times 100 and you would get the same answer. So you would get 135 with 2 zeros at the end. And then you have 2 numbers to the right. So you would put it here and get 2 numbers to the right. So either way, you're going to get the same exact answer. But if you remember this trick, it will be very helpful. So I'm going to have you try this one using the trick. It says a $50 is 2.15 millimeters thick. How high is a stack of 100 $50? So you're multiplying 2.15 times 100. Count how many zeros are in your power of 10 and move your decimal that far to the right. So that can be the trick. Okay? Pause and try that. I'm going to try one more of these and then I'm going to have you do the other 3. So you could just watch the first one. Again, you put the number with the most digits on the top. Put the other number on the bottom. You can just kind of slide it to the right. Multiply like normal. 8 times 3 is 24. Carry the 2. 8 times 2 is 16. Plus 2 is 18. Carry the 1. 8 times 1 is 8. Plus 1 is 9. Count how many digits are to the right. There is 1 number to the right. Again, the whole number doesn't count. So I'm going to put my decimal here so I have 1 number to the right. So you're going to pause and finish up the other 3 here. So make sure you pause and do those 3 on your notes. Now we're going to try multiplying a decimal times a decimal. So again, you put the one with the most digits on the top. In this case, they both have the same amount, so it really doesn't matter which one we put on the top. This one, it doesn't have to be lined up either, but obviously if you have the same amount of digits, it's going to look lined up. So I'm going to multiply it like normal. 2 times 8 is 16. Carry the 1. 2 times 4 is 8. Plus 1 is 9. I have to start my second row with a 0, just like you would with normal multiplication. 7 times 8 is 56, carry the 5. 7 times 4 is 28, plus 5 is 33. Add my 2 rows together. I get 6, 15, 4, 3. Now I have to count how many numbers total are to the right of both decimals, because now they're both decimal numbers. So I have 1 to the right here and 1 to the right here. So that's a total of 2. So I have to strategically place my decimal point so that there's 2 spots to the right. If I put it here, I have my 2 spots to the right. So if both numbers are decimals, you have to count how many are to the right of both of them. Okay, so let's try one more you guys can watch. This one has more digits, so I'm going to put it on the top. 3.1 is just kind of smushed to the right, doesn't have to be lined up. 1 times 5 is 5, 1 times 0 is 0, 1 times 0 is 0. Start my second row with a 0. 3 times 5 is 15, carry the 1. 3 times 0 is 0, plus 1 is 1. 3 times 0 is 0. Add my 2 rows. Now I have to figure out how many numbers total are to the right of each decimal. There's 2 on the top, 1 on the bottom. That's a total of 3. So I'm going to strategically place my decimal point here, so I have 3 numbers to the right. So however many decimals are to the right of the decimal numbers, that total is how many you need to the right in your final answer. So I'm going to have you try all of these. I know that's a lot, but I want you to try regular multiplication, count how many numbers are to the right, and that's how many you need to the right in your answer. So pause and do all of these ones. The last one here, where you would apply this in the real world. So the first one, it says you buy 2.75 pounds of tomatoes. You hand the cashier a $10 bill. How much change will you receive? Okay, so we're only looking at tomatoes, which is $1.89 a pound. And we're multiplying that by 2.75 pounds. So first step is I have to multiply this together. 5 times 9 is 45. 5 times 8 is 40, plus 4 is 44. 5 times 1 is 5, plus 4 is 9. Start my second row with a 0. 7 times 9 is 63. 7 times 8 is 56. 56 plus 6 is 62. 7 times 1 is 7, plus 6 is 13. Start my third row with 2 zeros. 2 times 9 is 18, carry the 1. 2 times 8 is 16, plus 1 is 17, carry the 1. 2 times 1 is 2, plus 1 is 3. I'm going to add all of my rows together. 9, 10, 11, 19, 10, 11. Okay, now I have to figure out how many decimals. There's 2 to the right and 2 to the right, total of a 4 to the right. So if I put it here, I have my 4 numbers to the right. Now, we want this to look like money, so money would only have 2 numbers to the right. So my options are $5.19 or $5.20. Because the third digit is a 7, which is 5 or more, let it soar, I'm going to round it up to $5.20. Now it's saying we paid with a $10 bill. So we have to subtract and see our change. Remember, when you're subtracting, you do need to line everything up and add zeros. 0 minus 0 is 0. I can't do 0 minus 2, so I'm going to borrow from way over here. I get 8, bring down the decimal point, and 4. So my change is $4.80. So when you're multiplying, you don't have to line them up. Count how many numbers are to the right. That's how many you need in your answer. When you're subtracting, you do need to line them up, and you do need to add zeros. Okay, this is the last one that I want you to try by yourself. Figure out how much change you would get back, multiply, and then subtract.